Welcome to today's lecture on moment of inertia. So in the previous lecture, we have already solved few numericals for the moment of inertia, wherein we have used only hardly a single sections like a rectangular section, triangle section and a circular section. And we have found out for hollow rectangular section and hollow circular section. Today we shall see a composite member and we shall divide the geometries like how we do in the finding out the center of gravity. So let us see. Find the moment of inertia of the angle section 150 mm by 100 mm by 10 mm standing on 100 mm side as a base about is centroidal x-axis and y axis. So the angle section is of 150 by 100 by 10. 100 mm is the base. So its CG will lie somewhere here. So this is the x-axis and y-axis. They have clearly mentioned that we have to find out about centroidal x-axis and y-axis. Now let us divide this triangle, this section into two sections. One is this and the other one is this, into two rectangulars. So first we have to find out what is the value of x bar and y bar. So remember, always we have to find out first the CG and then the moment of inertia. So let us find the center of gravity. Now I have divided the section like this, wherein the first section is of dimension 150 by 10 and the second section is of dimension from so much. So 100 minus 10, so 90 by 10. So let us find. So for this section 1, as we already solved this, you already know. So a1 is equal to 150 by 10 is equal to 1500 mm square. y1 is nothing but 150 divided by 2, 75 mm, and x1 is nothing but 10 by 2, 5 mm. For section 2, a2 is equal to 90 into 10, 900 mm square. Then y2 is 10 by 2 from base 10 by 2, 5, and x2 is nothing but 10 plus 90 by 2. So x bar and y bar is found out like this, that is a1 x1 plus a2 x2 divided by a1 plus a2 and a1 y1 plus a2 y2 divided by a1 plus a2. So we got x bar as 23.75 and y bar as 48.75. So we have located the CG now, that is 23.75 from left section and from the bottom 48.75. This is the location of CG. Now this is the CG of the L section. So we have to find out about this axis. So this will be our x-axis and y-axis as represented in the previous figure. So x-axis and y-axis. Now we shall find out the moment of inertia. Let us find the moment of inertia about the x-axis. So obviously we have divided this section into two rectangulars. So rectangular section, what is the moment of inertia? BD cube by 12. So let us find. So IG1, so BD cube by 12. IG1 refers for the first section. So parallel to it is 10 mm and perpendicular to it is 50 mm, perpendicular to the x-axis. Hence parallel will be B, perpendicular will be D. Hence BD cube by 12, B will be 10 into 150 cube by 12. We got so much. And the distance of CG of the section 1 till the axis. Now, how to do this is the section about height. So its CG will lie at 75, but here it is at 48.75. So we have to, because this is one rectangle whose CG will be lying at 75 and this is of the center section, so we have to shift the center of this rectangle section towards the main CG. So it will be 75 minus of 48.75 h1 distance, hence 26.25. Then similarly for x-axis, so ig1 plus a1 plus h1 square. So ig1 is there already, 28,12500 into area we have, that is 1500 into h1 square, we got so much. Similarly for ig2 is bd cube by 12. This is second section. Now parallel to it is 90 mm and perpendicular to it is 10 mm. Hence it is 90 into 10 cube by 12. Distance between the CG of the section 1 about x-axis is, now this section is about 10 mm. So what will happen? We have to deduct. So 48.75 minus of 5, 43.75. That is nothing but, if you see, this is half section here, 5. This has to be shifted here. So out of total, I will deduct so much. So 5 mm is deducted. So 43.75. The total Ig2 will be Ig2 plus A plus H2 square. We got so much. Total Ixx will be Ig1 plus Ig2. So adding both value Ig1 and Ig2, we got this. So this is the value of I-axis. Now let us find the moment of inertia about y-axis, that is about y-axis. Now this is the y-axis, so if this is a section, parallel to it is 150, perpendicular to 10 mm, and for second section it is parallel 10 mm and perpendicular 100 mm. So Ig1 will be 150 into 10 cube by 12, and CG distance will be, already we know that this is 23.75 and its CG will lie somewhere here. So 10 minus, so 23.75 minus of 5, that will be the section. Ig2 again along this, so parallel to this is 10 mm, perpendicular to it is 90 mm, hence it will be 10 into 90 cube by 12, and it is nothing but 55 minus 23.75. So finding out I by y is equal to Ig1 plus A1 H1 plus Ig2 plus A2 H2 square. So we got so much. So this is how we have to find out the moment of inertia about x-axis and y-y axis. Generally, such kind of numericals are asked in the examination. Now let us solve one more numerical. Find the moment of inertia of a T section with a flange as 150 mm and by 50 mm and the web as 150 mm by 50 mm about x-axis and y-y axis through the center of gravity of the section. Remember, T section is like this. Now this portion is called as the flange and this portion is called as the web. So flange is 150 by 50, so 150 by 50 mm, and the web is 150 by 50, so this is 150 by 50. First again we have to find out the CG. So let us divide into section 1 and section 2. If I take flange as the section 1 and the web as section 2, this is how we get it. So section 1 area is 150 by 50 and x1 is from here left side 150 divided by 2. Y1 is this 150 plus 50 divided by 2, 175. Let us take for the section 2. So area is 150 by 50 is equal to 7500 square. Y2 is nothing but 150 divided by 2 and x2 is nothing but 75, which is at the center. So we will get x bar as 75 as it is symmetric, and y bar is a1 y1 plus a2 y2 divided by a1 plus a2. So we already have this a1 y1 a2 y2, substituting we got this. So x bar is 75 mm from the left and y bar is 125 mm from the bottom. So we got the CG. This is a CG point. Now let us find a moment of inertia. So moment of inertia about x-axis. So x-axis for first section. This section. So Ig1 is equal to BD cube by 12. So x-axis is this. So parallel to it is 150 and perpendicular is 50. So B will be 150, D will be 50. So BD cube by 12, 150 into 50 cube by 12. This is the answer. Now the CG distance H1 we have to find out. We already know that this is 175 mm Y1, but our CG is at 125. So 175 minus 125, always higher minus lower. So 175 minus 125, 50 mm. So let us find the moment of inertia of one section about x-axis axis. So Ig1 plus A1 H1 square will get so much. Similarly, we will find out the for the section 2. So this is a section 2. So if x-axis axis, so this is B parallel and perpendicular it is D. So BD cube by 12, that is 50 into 150 cube by 12. And the CG distance is nothing but, we already know that this is here 75 mm, but our section is 120. So higher minus lower, 125 minus 75, that is y bar minus y2. So 50 mm. So finding out the moment of inertia Ig2 plus A2 H2 square, we got so much. Adding Ig1 and Ig to this component will get Ixx. So this answer plus this answer for section 1 and section 2 will give the final answer for xx axis. Now let us find out for the y axis. Y axis is symmetric about the central axis, hence no need to find out to multiply by area into this. This will become 0. So hence mi for 1 is equal to bd cube by 12. Now it is along y axis. So if I take section 1, parallel to y axis is 50. So this becomes b and this becomes d. So 50 into 150 cube by 12 is equal to so much. Similarly for section 2, this is section 2. So parallel to it is 150, perpendicular 50. So 150 into 50 cube by 12. So we get. So adding both, we get so much of answer. So this is how we have to find out the value of moment of inertia. So please do practice. Thank you. Be home. Stay safe.